Hey everybody, it's Mrs. Slauson. Here is ICAN 12 first attempt. So in our first section, we're going to write each expression in its opposite compatible form. So if it's an exponential problem, we're going to write it as a radical, so we'll have a check mark. And if it's a radical or a check mark, then we'll write it as an exponent. And here is the general format for these problems. So the denominator of my exponent fraction will become this little index number. And then after wrapping it in parentheses, the numerator of my exponent will become the exponent of my radical. So first thing I'm going to do on number one is just take 3n, wrap it in parentheses. I'm going to acknowledge that there's technically an invisible 1 there, and that becomes to the 1/5 power. The one that's similar to that is the one below it. So I'm going to take x, I'm going to wrap it in parentheses, and then my exponent fraction will be 4/3. And on the other two, I want to put them in radicals. So 10p will go there, and then the denominator becomes the little index number, wrap that in parentheses to a 2nd power. And then on number 4, I'm going to have 3x. My index number is the denominator, it's the 5, and then wrap that all in parentheses, and it's to the 4th power. The next section, you will be expected to use your exponent table. If there is not work shown, you will not get credit for this section. The idea is we do not know what 81 to the 3/2 power is. So the first thing...
Attention Raptors!
So I'm going to rewrite this as a radical. 81 goes in the check mark. The 2 is my little index number, and then to the 3rd power. So this is the first expectation of what you will be asked to do. And then from there, you can use your exponent table. All right, I had to pause for the bell. So anyway, what I could do is look at my exponent table if I don't know the square root of 81. And so just a reminder of how this works. Sorry that it's sideways, but I would find my x squared, which is here. And then I'd scroll down, look for 81, and then I could scroll over and see that the square root of 81 is 9. So the idea is this becomes 9, and then I could also use my exponent table to go from 9 to the 3rd power. So what I would do is scroll along the side, find 9, and then I could go over to the 3rd power, and I'm going to see it's 729. So again, the idea is without the calculator, you will be expected to show those steps. So on the next one, 625, I'll take the 4th root of that and take all of that to the 1st power. Using my exponent table, again, I would look for my 4th column. X to the 4th, I'd scroll down until I see the number that I need to see, which again is 625. And then once I find 625, I can go back over and I'll realize that it's 5. And then 5 to the 1st power, if this wants to write. Very temperamental. Let's try a different color. Is 5. So the others real quick, rewriting them. The cubed root of 125, and then take that to the 5th power. The cubed root of 125 is 5. And then 5 to the 5th power is going to be, 3,125. And finally, the last one, the 5th root of 1,024. And then I'll take whatever that amount is and square it. So again, just to show you one more time, I would look for 1,024 under my 5th root. If I go all the way over, I'm going to see that belongs to 4. And then from there, I can take 4 to the exponent that it needs to go to. So 4 squared, and I get 16. All right. Solving. So our goal is to solve for the variable. So let's start with number 9. I want to be able to get to these r's, but I can't get to the r's unless these square roots are gone. So I'm going to square the left side, and whatever I do to one side, I do to the other side. I'm squaring the whole thing. The square roots basically just disappear, and I get this, and now my goal is to get r alone because there's the same type of r. So let's put some 1s in front of this. And the first thing I'm going to do is add 1 r here. And now to get r alone, I'm going to subtract the 3, which gives me 8. And then when I'm done with that, divide by 2, and I get my r to be 4. So let's double check that this is not an extraneous solution. So I'm going to move this over just a little bit. The idea is we can go ahead and go to our calculator, Let's get a different color going here. And I'm going to put 4 on the left side. And I'm going to put 4 on the right side, and I do not have my calculator up. So if I take 11 and subtract 4, I get 7, and if I take 4 and add 3, I get 7. So I will get the left side to equal the right side. So 4 being my answer gets to stick. It's not an extraneous solution. All right, next one. I want to start getting P alone. So first I'm going to add my 3. That's going to leave me with 8. And now to get to everything under the square root, I'm going to square both sides. That cancels out my check mark. And 8 squared is 64. And now, whoops, that is, I just realized I did not write that correctly. It's 11p. Sorry about that. Looked like a 16. And now to get my p alone, I'm going to add 2. And then after I divide by -11, my answer is -6. So let's see if -6 works. So again, I can go to my calculator. I can type in the entire left side. You can do that. I will not use the calculator. What ends up happening is I will subtract or multiply my -11 and -6 to get 66. And then if I clean up my radical, I get 64. The square root of 64, whoops, and this is a -3, I lost that along the way, is 8. And as it turns out, the left side does equal the right side. So P being -6 is the solution. All right, 2 more. Let's start with 11. And on 11, what we're going to do is we got to get to that x, and the x is under a squared. So just like before, I'm going to square both sides. The left side becomes -10 plus 7x. The right side is just x squared. And now with more than one type of x, we will want a factor. So I'm going to add my 10 to the other side and subtract my 7x to the other side. But when I do this, I'm going to write it in standard form. So this should look familiar to you. And now all we need to do is factor. So I need to find factors of 10 that make -7. So that'll be a -5 at the -2. And then x times x makes this x squared. And then if I draw the face for these loops, an x multiplying with a -5 makes this number. And the x with the -2 will make this number. And now I can set each factor equal to 0 and solve. So I get 2 and 5. And now we want to see, do they both work? So let's start by putting the 2 in. So on the left side, I'll have, and again, you could just type this into your calculator and get there too. I'm just showing you what the calculator is going to do. So I get the left side to equal the right side. 2 being a solution works. Let's try 5 now. So putting 5 in for my x. Inside the square root, I get a 25, and yes, the square root of 25 is 5, so this also works. Number 12, I am going to change. Let's just make that a, change it to this instead. Oh, hold on, let me pause and think about this. All right, we're going to change this problem because we did not do the 3/2. So let's change it to this. And again, my goal is to get P alone. So the first thing I'm going to do is square both sides. And now to get P alone, I'm going to subtract my 37. That gives me 44. And once I divide by 2, I get 22. So let's see if that actually works. Again, we did not use this version of the problem. We used this. So let's do a quick check. So 9, Then I get 47 plus 31, that's going to give me 81, and the square root of 81 is 9. So that one works as well. So on this one, we actually did not have any extraneous solutions. And that's it. That's your first attempt.